operating. I'm not controlling the number of threads. Let's say I have 20 threads operating at parallel. What's happening now is that multiple threads are trying to get access of the counter variable. So something wrong happened. So instead of printing 100,000, I get 99,000 and stuff. One more time to explain this. I will go back to this slide. So why is this? I will explain you you can read it. The problem is with the IL, the MSIL, okay, intermediate language, intermediate code that the .NET uses. The IL does not think of counter plus plus as a single line of code. You write it as a single line of code, but it's not. What's happening behind the scenes is that the execution, during the execution, this line is transformed into 4 lines. First line will get a value, the current value of the counter. So let's say the current value of the counter is 2. Okay? It will get the value of 1 because counter plus plus adds 1. Now it has 1 and 2. Let's say stored on the stack, right? It's local variables. So you have 1 and 2, 2 being the current value of the counter. On the third operation, it adds the 2 numbers. Now I'm having 3. And on the final operation, it stores the result back into the counter. So that's how I get counter plus plus going from 2 till 3. Okay, so that's, okay, good IL lesson. What is this for me? Examine this screen. Here, imagine I'm showing for you the case where 2 threads are execution. I will explain to you now why I get some iterations not counted. Let's walk through this. I have thread 1, which gets the current value of the counter, which is 2. Okay? Thread 1 is also operating, and it got 1, which is the value it will add to the counter. Now, at the same time, before thread 1 continues, thread 2 kicks in. Thread 2 gets the current value of the counter, which is again what? 2. It is not incremented yet. Okay, that's the problem of parallel programming. Now, thread 2 gets, okay, one more time, the value of 1. Now, thread 1 takes control back. Thread 1 is working. Thread 1 adds the 2 numbers together, which is 2 plus 1. Now I get 3. However, when thread 2 executes again, it will also get 3. Is it clear for everyone? Why is this happening? Okay, so both threads get 3. What does this mean? Is that I have omitted the value 4. So I get 1 iteration which is not counted. Now this is what happened in my program. On the 100,000 iterations, this happened multiple times. So instead of counting 100,000 times, it counted 99,000 and stuff. Okay? So this is a classical example of a database. And it requires synchronization. So we need to synchronize. How do we synchronize? Who have ever, not necessarily worked, but who have ever heard of the concept locks? Okay. So you know about locks. In .NET it has been there forever. It's about locking an item, locking a value. The only way to solve these data synchronization problems are first option, utilizing locks. Second option, anyone? Sorry? All of these are locks. Other example, other solution, not use parallel programming. Okay, so we do not want that. So we want to use parallel programming, so we are stuck with locks. Now, locks has many forms. If you go to the .NET API, you have something called synchronization class, monitor.enter, monitor.exit. You have many stuff. But mainly, it all has the same idea. I will show you now the.
Now I have control over the thread. Maybe I can define a local variable per thread. Is it possible?
No, because it's a very good question. Here's the idea. The idea is that you want to write your code in a way which runs in a single thread and runs on a parallel machine. You do not want to write 2 versions of your code. So thanks for your question. Okay. You do not want to write 2 versions of your code. One to run on serial machines and one to run on parallel machines. What will happen now? Ideally, if you work in companies, what will happen now is that starting .NET 4.0, you will start writing your code to run on parallel machines. But you might expect it will continue to run on non-multi-core machines for another 1 year. What you want to do is that once you upgrade your hardware, your code will take advantage of the hardware, not the other way around. Okay? So we need to utilize logs. So what is log? This is a log. Okay, so it takes a variable, it puts a log on the variable. So if one thread, any thread that takes this variable will put a log. If another thread is trying to access the same variable, it cannot. It has to wait. Again, a typical question will be, but this has performance hit. Okay, so what does not? If you want to use parallel programming, these are the techniques that you have to use. Okay, so let's see how the logs will be utilized. Okay, in this region, I will show you, actually it's identical, so I will show you only one, which is the preferred method of doing logs, which is called interlocked. And interlocked has a method to increment. Okay, so I will not use the counter plus plus anymore. I will utilize .NET threading blocks, and I will lock my variable. This means that if any other thread is trying to access my variable, it cannot. It has to wait. So let me run the program again. So this time, you see it? Should I run it again? You saw it, huh? You didn't see it here? So now using blocks, first thing it will take more time. You will not maybe notice it. It's all milliseconds now. It's only simple loop. It's having a problem with the magnifier for some reason. So now it's utilizing blocks. Again, I repeat, it will take more time. But now it will print the correct number. It will print 100,000 iterations. Why is that? Because I'm utilizing blocks. Everyone can see it? Okay? Just small hint. If you remember, the previous one took 14 seconds. This one took 15 seconds. Not a major difference, but still. Okay. 10 minutes. Please. Okay, by the way, my time is done. I still have 2 demos, which is about debugging and about deadlocks. Should I continue or just stop? Okay, so now, you're doing parallel programming, that's great, but like everything, you need to debug. Errors will happen, and you need to debug. You cannot debug parallel programs the same way you debug serial programs. Why is that? Very simple reason. If you put a breakpoint inside a loop, if your program is serial, okay, you will start hitting F10, F10, and you will loop through your code. If your program is parallel, you have multiple threads executing. So you imagine what will happen. While you're doing F10, you will go from one line to another. Then suddenly you will see that the breakpoint or the execution is back to the first line. Why is this? Because multiple threads are trying to access the same code. Okay? So let me just show you this quickly. So this is a prime function. It's a heavy function. It has some additional code to simulate heavy processing. Okay, I know my machine. So what does this? It means that Microsoft Visual Studio is busy. It's definitely busy. So I will kill the process. Start it again.